Hey, Miller Computer Science students. This lesson today is going to be lesson number 12, Python Conditionals. So I'm going to go through my current lesson that I have, and then I'm going to have some Repl.it code right beside that, going through each section. Feel free to go through this and pause it step by step, because there's a fair amount that's going to be in here, so the video is going to be a little bit longer than some of the other ones. So let's get right into it. Lesson 12, Python Conditionals. Okay, first of all, the most important thing you're going to have is, well, not the most important, but we're going to start with our typical lesson 12 conditionals, and then we're going to have the print statement, does 3 equal 3? Okay, so when I switch over, you can see I've got this entire program here set up and ready to go. I don't want, every time I run it, there's going to be a whole bunch of code that's going to come up, and I don't want to confuse you. I want to go line by line. So this is also a technique that you can use if you have an error in your code. So if you have an error in your code and you try to figure out what's causing it, sometimes it'll give you an error message on the right line, but sometimes a different line is what's causing the error lower down. So if you wanted to comment out sections of your code to try and debug, this is how you can do large chunks of code commented out in Python. So I'm going to start up here. I'm going to leave line 1 and 2 in, but I don't want anything else in here right now. So to start with, I'm going to go right here. All I'm going to do is 3 single quotations. You can see it's now commented out the whole thing, but if I run the program now, I'm going to get an error. Oh, I didn't get an error. Sometimes you get an error. Oh, that's because I already have my 3 comments down here. So if I take those out, there's no ending point for the comments, so I get an error. This doesn't understand why I have this open bulk comment code and there's no close. So I close it down here, and then when I run my code, I get just the part that I wanted to. Okay, so that's valuable information for I use it lots for debugging, because you want to take out little chunks at a time to figure out where the real problem is. So let's start with that. Okay, so as we can see, this is just going to print does 3 equal 3. This is just a string. That's all it's going to print is does 3 equal 3. It's not going to actually check anything. We actually want it to check something. So when we come back to our code here, if I take out my 3 comments and I pull it down, put them down to here, now I have an if statement. So an if statement is an example of a conditional, because something else has to happen in order for that conditional to run. All right, so I have the keyword if, and you see it comes up blue, so we know that it's a keyword, and I say 3 equals 3. Now remember, we use equals 3, because if we just say 3 equals 3, that's also how you assign value to a variable. Okay, so by just using the single equal sign, that assigns a value. Using 2 equal signs is actually going to compare the 2 numbers. All right, so 3 and 3 both hold a value to Python, so it's not like a string, it's an actual number, so I can run this, and if 3 does in fact equal 3, it's going to print true. Okay, so when I run that, the computer runs down my code, carries out the commands on each line, and when it gets to line 3, it sees an if. It says, oh, okay, if. So now it takes in this information, 3 equal 3. This colon right here is important to have. Anytime you see a colon in Python, it means that the next line is going to relate to the current line we're on. Okay, so this is the action I want Python to carry out, that I want my program to carry out, if this statement is true. If this statement is not true, then I don't want it to carry out this line right here. And you can also see the indent. Indenting is important in Python. It's not in Java syntax-wise. Indenting in Java is important so that human beings can read your code, but it's not essential. The program will still run. Indenting in Python is a syntax, so you have to actually do that indent. So after a colon, we're going to have to indent to say this part is attached to this part. So this is this is the condition, this is the action. And you can even see when I click up here, I get this little minus sign. So I can close everything inside that colon if I want to, just to make my code more readable. All right, so right now if 3 equals 3, we print true. It does print true, but if we change that number and I run it, my true disappears. Now this is one of those dangerous things I talk about, because when we're dealing with the user, and think about yourself when you play a video game, if nothing happens, it's frustrating. What just happened? There was nothing there. And now I'm angry. I don't know what's going on. What am I going to do? Okay, I'm going to get angry. I'm not going to use this program. Now you're unsuccessful. So we don't want to have those things happen. Okay, so I'm going to come back to the lesson. Okay, I think I've gone through most of the sections in here. Now if we come in here, we're going to compare two numbers, but we're going to use a variable to do that. So remember, a variable is just a box, an empty box. We assign the value of 3, and y we assign a value of 2. Then we're going to print a label or a prompt, whatever we want to call that. Remember, we don't want to just start doing calculations. We want to explain to the user what's happening. All right, so by using this print statement, is x greater than y, and then we use the dot format to insert whatever the value of x is into this curly brace and whatever the value of y is into this curly brace. We now have a prompt or a label of what's about to happen in our program. Okay, so let's go back to there, and I'm going to get rid of my commenting here. You can see my x equals 3, my y equals 4, and then I'm going to come down here and say print is blank greater than blank, and then insert x and y respectively into those two sets of braces. Okay, so I'm going to put my code back in. Now I have my prompt. Is 3 greater than 4? Okay. From there, we're going to have our conditional. Okay, so if x is greater than y, print true. Now the question that should have jumped out, and we talked about it a little bit in the first part, is what happens if x is not greater than y? That's what we don't want to worry. We don't want to have happen. We don't want dead air to occur. We don't want nothing to happen when a program is executed. We want something to happen, even if it's the program to run and close. We want something to happen so the user knows what's going on. Okay, and that's where the other half of the Boolean comes in. Okay, so a Boolean is either true or it's false. All right, so if x is greater than y, this statement is true. But if x is less than y, the statement's false. And that's where we have to use this else statement. So if this is true, do this. If it's not true, do this. Okay, again, colon to indicate there's more information coming, indent for the true statement, and we have another keyword else with a colon, meaning that there's more content coming, an indent, print false. So when the computer gets to this line, I'm going to show you in here. So I have my statement right here. If x is greater than y, print true, else print false. So when we run this, x is 3, y is 4. So this statement is not true. So when we run it, we should get a false printout. Okay, so there we go. There's our false. All right. Is 3 greater than 4? False. It's not greater than 4. Now if we change our values, which I think is what the lesson has us doing, we switch these around. Now x is greater than y, and we get a true. Okay, my line 3 is no longer printing, if you were wondering. Line 4 is no longer printing because I don't have an else statement in here. That's why we're not seeing a false and then a true. I don't have anything else in here. Okay, I'm actually going to comment that out separately so that it doesn't come back at all. Okay, so now I've tested this. I've reversed the variable values, and I've gotten two different answers. Okay, x is greater than y, or x is not greater than y. Okay, so I reversed it. Okay, there's other comparisons we can make as well. We can include something in there, and that's what happens here which the statement can still run. If I make x3 and y3, it says false. Is x greater than y? No, it's the same, so it's false. All right, but I can change this, and I can add an equal sign in here and say if x is greater than or equal to y, print true. So it's printing false right now because before I didn't have the equal sign there. So when I run it, changes to true because it is now saying, oh yeah, it's not greater, but it's equal then. So that runs this line of code. Now this line of code never runs. As soon as the statement is true here, as soon as this statement is true, it runs this and then it moves on. Okay? Hopefully you're still with me. All right, so now a more complex example. So we're going to start off by creating two player variables. Player A equals rock, player B equals scissors. From there, we're going to write some code that will compare the two. If player A equals rock, or player B equals rock, we're going to print out someone chose rock. Okay, so we're going to have this down here. Alright, so, oh, this one's not what I wanted. Comment that back out. Okay, we'll come down to here. Okay, so this is the section I want to work in. This was just another example I must have put in another time. Okay, so here's what we saw from the lesson. Player A equals rock, player B equals rock. Now, if player A equals rock or player B equals rock, print this. Okay, and then I have another if statement right here. It's going to be different. Okay, so I have this code in here that says, is this helpful? It's not really helpful, but it's helping us to figure out the difference between or and. That's what we want to find out the difference between. Okay, so in a conditional statement, when you use the word or, either statement can be true. Okay, so you can see here we've put in two different statements. We're saying, is this true or is this true? As long as one of them is true, it's going to print the true statement. Okay, so let me actually comment this section out. So in this one right here, I've assigned a value of rock to both of these. So when I run it, let's comment the rest of this thing out completely so we're not messing with anything. Okay, so I get someone chose rock, all right, which is my string that I've put in right here. So what I know when I get this output is that either player A or player B, the value of those variables is rock. Okay, like I said, this is not helpful, but it helps us understand. So if I change this one to, I can never spell scissors, so I'm going to say paper. If I change player B to paper and I run it, I still get my positive, my true output. All right, because even though player B is not rock, player A is rock, and we used an or statement. Okay, and I can change that around the other way and have the rock statement come from player B. And when I run it, I still get my someone chose rock output. All right, that means all that's saying is no matter what, as long as one of the variables or one of the conditions put into the if statement is true, then the positive runs, the true statement runs, regardless. Okay? Now, if both of these are no longer rock, and I run it, I get that thing that's probably one of the most dangerous things you can get in an output when dealing with users. Nothing. There's no content. There's nothing coming out, and now I'm confused and don't know what's going on. Okay? That's where the and will come into play. Okay? We need an else statement in here. So as long as these two aren't rock, print, nobody chose rock, or whatever you want to call it. But right now, either one of these has to be rock. The other interesting thing about an or statement is as soon as it gets a positive, when you're using an or, as soon as it gets a positive, okay, as soon as it finds a true statement, it stops reading that if statement. So it's not going to read the second if statement here because it already found it's positive. Okay, it doesn't have to read the rest because as long as one is true, it runs it. Okay, so let's bring this back out and we'll come into this one. Let's go back into the lesson and look at what happens. Okay, so this was the first section. Okay, in order to accurately play the game, we'd have to be a little bit more specific with our code. Okay, we have to use the command elif, which stands for else if, which is what you're going to use if you have multiple options that can occur. So if you look here, we have player A equals rock, player B equals scissors. Then we say if player A equals rock or player B equals rock, someone chose rock. That's the one we just went through. Now here we're going to say if player A equals rock and player B equals scissors, print player A wins because we know rock beats scissors. Then we have an elif. If player A is rock and player B is paper, player B wins. So anytime these two, the value of these two variables equals out this way as paper and rock, player B is going to win because it has paper. Okay, because we know paper beats rock. And then the best way to do the ties is just to say if it's neither one of these two, print tie. Okay, so I understand there's stuff missing there, and that's fine, but let's look at this section right here. Okay, so now we have that section from our lesson is now here. So we've assigned rock and paper to these two right now. So we're saying that if player A equals rock and player B equals scissors, print player A wins. Well, right now it's rock and paper. Okay, so this elif says player A equals rock, player B equals paper, print player B wins. Else print a tie. Okay, so I have these two, rock and paper, and I'm going to get player B wins. Okay, if I change them around and I change player B to scissors and I run it, it's now going to say player A is rock, player B is scissors. I spelled it wrong. I always spell it wrong. Scissors. And I run it, I get player A wins. Okay, this statement is true, so it prints this one. Else check this statement. If that one's true, print this one. If neither one of them are true, whatever else you get, print tie. So if I change it to something ridiculous, now I get a tie, which is broken code because that's not how the game of rock, paper, scissors works. It shouldn't say tie. It should say you're an idiot. You entered something you weren't supposed to enter. Okay? But if we both have rock, then it enters tie, and that's the correct entry that we're looking for. Okay? So when we come back down here, I've explained what each line checks. Okay? This is not the true game of rock, paper, scissors. Contains almost all the code you'll need to create it, though. Here are some steps that are missing. In the real life game, there's 3 choices per player, 9 different combinations per instance of the game. Okay, 3 of the combinations are a tie. 3 indicate player A winning, and 3 indicate player B winning. Okay, I put a winky face, an old school winky face here. So I wonder how much work it would actually take to do that. Okay, that is the end of the lesson. That is your breakdown for conditionals. As always, if you're confused or need help, go back through the lessons that I have with screenshots. You can rewatch the video, pause it at specific points, and try and get all those lines of code to work for you. And then you can move on to the assignment. Okay?